Yeah, I hope you had a nice evening and you enjoyed not only yesterday's lecture but also the dinner. I would like to give you a brief introduction into what we call the Materials or Nomad Encyclopedia. And let me start right away. You have seen this transparency already. And the talk is all about this orange box here. So it's how we give access to the data. So in fact, what you have seen so far is that we collect millions of calculations in the repository, and then we make them comparable to each other by normalizing them. And these data are sitting in the archive, but they're still data. So these are files where you can have a look into if you're interested in, but it doesn't show you what is inside the files. So what we came up with is the idea of the Nomad Encyclopedia, which is dedicated to the, which purpose is to display all the results that people have computed all over the world. So in other words, it's not the file-oriented or the data-oriented view, but we would like to provide you a materials-oriented view on the data. So that allows then for seeing this data, comparing this data to each other, inside the calculation, so it has been calculated. So where to start with? Maybe you have seen already, we provide now parsers to a lot of codes. These are more than 30. A few more are going to come. Well, so this is the list that's at the moment at the repository. But then we have different basis sets because these codes, they have implemented different methods, and these methods come with different basis sets. So this is probably 10 or even more of this. Then we have different methods. So most of the calculations at the moment are density functional theory, but there's also quite a few calculations already on ab initio molecular dynamics. There is also classical molecular dynamics already implemented. We have also some quantum chemistry codes. So this is not yet done, but it's coming, wave function-based methods. Then we have many-body perturbation theory in order to do spectroscopy or GW. And there's more methodology to come soon. So in essence, let's say we have also something like 10 different methods implemented. Well, then we have materials. Materials are practically infinite. I think this was pointed out by Matthias well enough in the first day. Then we have systems. So materials can either be bulk crystals, could be surfaces, 2D layers, 1D chains, molecules, nanoparticles, adsorbate systems, interfaces, nanostructures, you name it. Could even be more complex systems like systems with different grains, complex alloys, things like that. So to keep the things short, let's say we have 10 different systems also. And then we have properties, so structural properties, electronic properties, vibrational, thermoelastic, spectroscopic, and things like that. So depending on the people's interest who have developed the code, of course, some of the codes implement one or the other a class of properties in more or less detail. So there's also quite some variety. Let's say we have 10 different categories here. So functions, there's thermoelectric materials, solar cells, light-emitting materials, catalysts, superconductors. Let's say we also have something like 10 functions. Now, if you combine everything with everything, because you could compute several properties with different codes, with different basis sets for many materials, so you have a space to explore which is tremendous. So nearly all kinds of combinations are basically possible. And then don't forget that we have users, and these users are those people to which this encyclopedia is aiming at. So we have users from academia, of course, maybe the people who have calculated this, all these properties, but also are just interested in them. We have industrial users. We have also the interested general public. So think about also there may be people or pupils in school who are interested in materials and they would like to know what the encyclopedia is about. So how to do this, how to plan such a thing, what to give priority. And let me guide you know what we have come up with. So the idea is to give materials the property, the priority. It's not the data, as I said before, but the material should be displayed. So you could search for materials either by the elements that are involved, or by the chemical formula, or by its properties. Then you will get a list of all these materials that fulfill this criteria. And from this list, you can choose the material you're interested in. And then you are getting an overview of the material you're interested in. And after this overview, then you can go into more details, because this overview tells you already what we know about the structure, something about the methodology, the electronic structure, and the thermodynamics. And in all these categories, you can go into more detail if you like. So how does this look like? This is, unfortunately, something is wrong again with the resolution of this beamer, so it's a bit blurred. I hope you still can get the essence here. So, for instance, you may want to select by element. So I enlarge this a bit, at least I hope, yeah, it helps a bit. So you can choose the material by clicking on the elements that are involved in this material. And then you have a guided tour here. For instance, you have selected iron and oxygen. So these elements appear up here. So these are the elements we have selected. And then we go into more detail here, because you can select the elements that are inside the material, and there may be other elements in this material, but you can also use what we call an exclusive search. If you just want to focus on those materials which have iron and oxygen only, then you click on this box here. And for instance, here we have also chosen cubic and trigonal materials. Okay, then you may add properties. So you may choose from the list of properties that we have implemented, like electronic properties, band caps, whatever you may choose. You will explore everything else then in the tutorial session. Well, and once you have selected everything, then you are getting a guided tour here how to search for this. So these are the results. As I said, once you have selected a material, you will get an overview page, and this overview tells you what the results are, what you have found in the repository, or what we have found in the encyclopedia. So as you see, you have selected iron and oxygen, and this comes in different variants, just iron oxide, FeO, or Fe2O3, or whatever you like. So you have a list of materials here. It tells you also the system type. In this case, it's all bulk. It tells you the space group of this material. It also tells you something about the structure type, if it's known, for instance, rock salt and so on. And then it tells you how many calculations of this type and of this material you have. And if you zoom in again here, then you will see that for some of the materials, we have an enormous number. So for one of these, we have even 576 calculations. What does it mean? Obviously, several people have done the same calculation, not the same, maybe with different functionals or with different codes. It could also be that there are many calculations inside because people have optimized the volume. So obviously, there are many calculations with different, maybe crystal, not only crystal structures, but lattice parameters or internal coordinates. And this also gives us a headache because we have to think about how to display these things. So we have to guide the user in order to make use of this rather than disturbing the user saying there's 576 and then choose whatever you like. So you don't want to go through this, but you would like to see a structure in the whole thing. So, and this is what you get then. This is the overview of a material. So it gives you a box which tells you what the structure is. There's another box on the electronic structure. We have one on the methodology, and depending on what category is available for this material, you may have more of these boxes in the results page. So this is just an overview, so it gives you the most important thing, yeah? Sure. Yes. So we don't show pictures that have been uploaded because, first of all, this is not often the case. and we want to have it in the same form. So as you see then, if you have more than one calculation, you can click through the calculation, and then you will get in the same unit format all the results that are inside. So as I said, this is just an overview. In this overview, you see the crystal structure. For instance, in the electronic structure, you see one material which is representative. For instance, we would choose a material where we have both the electronic structure and the density of states. If we don't have it from the same calculation, we will nevertheless display one and the other, but telling you, for instance, in this case here, you cannot even read it, it's maybe two different calculations if it's not available. If it's available, we show it from the same. So this is structure, electronic structure, methodology. There's also thermal properties, so depending on what is available for a particular material, you will see different things here. Now what is also important is you can download the structural properties in order to use the virtual reality tools that you have seen yesterday. So there is a download button here. And then you can go in any of these boxes into detail by clicking on this plus. And I've now just chosen the structure here. And what you get is common information. So this is the structure, which tells you the structure type, the crystals, the crystal lattice, the Wyckoff positions, and these kind of things. So don't focus on the detail. It's just how to guide you through this thing. Common information on the left-hand side. Then we have a tree with all the calculations. Okay? And then you can, I show it in a minute a bit more. So you have different functionals, you have different codes, and then you have the different calculations here. And from this tree, you can select what you're most interested in. And for this selection that you have done here, you can get a summary then about what the lattice parameter of these materials of all these calculations is. And if you just, let's say, choose GGA here, it will give you the summary of GGA. If you choose LDA, you will get the summary of LDA. If you choose a mixture of it, then you will get the summary of all of this. So common information, the tree where you can select the calculations you're most interested in. And on the right-hand side, you see then the corresponding results, also what you have selected. So for instance, here we have selected GGA, exciting, and the list of calculations. And as you see here, they have been already grouped to show you the energy versus volume curve. Now I'm going back to the question I raised before. So what to do if you have many calculations inside here? So you have to group them such that it makes sense. And one of these groupings is if we see that, for instance, there are several calculations where the computational parameters are exactly the same, but only the volume or the crystal structure is different, then we can display it in terms of a equation of state, volume versus energy versus volume curve. So, but you can also click on the single calculations. If you look here, there's one point which is highlighted, and obviously for this point, you see here the lattice parameters and more details of the particular calculations. And here you see a bar where you can click right and left, and then you can go through all these calculations and compare what is the result of these different calculations there. So let's go back to the calculation tree, as I said before. Or let me come to the very beginning. What is in the focus of the whole thing is the material. And that's why if you look at the calculations, the material comes on top. So this is what you have chosen. In this case is, for instance, iron. The next important thing is the methodology, because you don't want to compare apples and oranges. You want to compare results that have been computed with a certain methodology. So in that sense, we have chosen it to be the second important thing here. But then, of course, you also want to know what the code is. People have calculated the things, and this comes next. So for instance, here for this iron and GGA, we have two types of calculations, 3 calculations that come from FHI AIMS, 10 calculations come from exciting. And then if you can, let's say, open and close these boxes. If you open this box, then you will see that all these calculations that are inside here. Yeah? Yes, a surface is, we regard a different material. So in the lists, I can go back later then. In the list, you see all the materials that fulfill the search criteria. And it's characterized like bulk, surfaces, whatever we have in this list. And then you can choose on the list what you like to see. So a surface would be separate. You can also search for iron. And this will be an adsorbate system if you have a molecule on it. It's not yet implemented, but it's coming. Yeah. In the results page, it will show up. You can explore everything then what is there, and actually it's also very important for us to get feedback what is missing, what you would like to see. So you are basically our, let's say, guinea pigs here. Okay, so most important material, then comes the methodology, then comes the code, and then the different calculation. And there you see already our grouping. So for instance, this is the equation of state I've shown before. So we have 7 calculations that have been grouped to give you this energy versus volume curve. There's also groupings according to the computational parameters. So maybe you want to see what the effect of the basis set sizes of the K-match sizes. So if, for instance, the volume is the same, or the structural parameters are the same, but the computational parameters vary, then you would get a group where all the different computational parameters are linked together. So codes, and then we have the individual calculations. So let me go now again to this plot in a bit more detail, or a bit larger than before. As you see here, you get this energy versus volume curve. You get the minimum energy, which is here. And then if you go through, it will tell you, the machine will tell you what is the energy difference. And then you can click through all these calculations, and you will see more details on these individual points and the results of these individual points. Like lattice parameters and things like that. So what else do we have implemented at the moment? Additional information. As I said before, if you select a few calculations, you will get some statistics on this. This is a summary. For instance, now this is a summary for all the GGA calculations we have in here. It tells us that the minimum or average lattice parameter is this value here, but this is the range of calculations that you have selected. Gives you the volume, density, atomic density, and things like that. In 2 different forms. You can also get it in terms of bars here. It's the same thing. So how either this or this. So how often a calculation, a type of a calculation appears. So, yeah. No, this is a summary of all the calculations that are inside there. So it tells us we have probably 1 calculation calculated with this volume. We have 2 with this volume, another one with this, another one with this. Also gives you some idea either of outliers, for instance. So what else? We also have thermodynamics. You can explore it later yourself. So phonons, thermal expansion, specific heat, other properties derived from this. We have an information system which helps you going through that. It shows you information about the quantities that are computed. It shows the methodology behind, for instance, if you want to know more about a certain functional, there will be a link, for instance, to the original paper. There's also links to Wikipedia and things like that. So there are external links and much more. We have information also on the methodology, method, functional, code version. If you just are interested what the basics behind density functional theory is, then maybe a link which guides you there. Yeah, there's also more to come. In the near future, we are working on quite a few things. The information system will be enhanced, so we would like to have various levels, because having different users in mind. We would like to provide different information, for instance, for the experts, and different information to those people who are novices or don't know much about the whole thing. So we should have different levels of this here. We will also expand the system type. At the moment, we have basically implemented bulk and 2D systems or surfaces. This is the ballpark of the repository and the archive at the moment, because most of these calculations, as Matthias has pointed out, are quite many, come from EFLOLIB materials project, which basically treat bulk materials. So there are many millions of bulk materials in there. But we're working at the moment 1D materials. This is on the way, being implemented, surfaces, molecules. We extend the properties that we treat at the moment. Fermi surfaces are on the way to being implemented. We have some basic implementation of GW. It will be more soon. We will implement elastic properties, also with interactive tools to play with, and we will expand the methodology in terms of molecular dynamics. In the future, or hopefully not too far future, we also plan to extend it with respect to experiment and also complex systems, so to going to a little bit larger length scales that we can do now. So, ongoing work, I mentioned that we're implementing molecular dynamics. This is the planning document I would like to share with you. So it shows you how complex such a simulation is, and in particular molecular dynamics brings in two new features. One is time, so we would like to show all the properties as a function of time, and the other is it brings in also temperature, and this of course requires quite more thinking than what we have right now. So some property as a function of time or as a function of temperature should be displayed. Yeah, so this was a basic overview of what we have done. You will hear much more now about the idea how to plan such a platform. And I hand over either to Luz or to you, and thank you for your attention.